we will focus again on some questions around study units 8 and 9. So let's get going. So again, in the presentation pack, what I will share with you guys is some of the theory and some of the formulas, as I will also go back to those formulas when we need to. One other thing that you guys might pick up is with your assignment, and try to do it as many times as you can. But it might be that when you do it the first time, you suddenly see you get 1 out of 2 or half out of 2 or something like that. And that normally happens when, like this example, we need to use maybe, and I don't know what we're going to use, but if you use a Z test instead of a T test, and you still get confidence interval, they might give you 1 out of 2 because you still followed the process or you still used some of the information. So that is when you might get a half mark or 1 mark out of 2, is that your answer is wrong, but you did maybe do some of the steps correctly. Okay, so that is when you will get sometimes a mark or 1 mark, 1.5, or half mark is when those things happen. Okay, so let's look at this question. And again, this is from all the previous assignment, or from your mock assignment, or from other ones that I had. So let's look at the information and then we decide what to do. A household survey based on a sample of 50 households in a small rural village found the average household income and standard deviation is 1,000. Construct the 99% confidence interval estimate for the population mean, and then they give us options. Okay, so firstly, let's see, are we working with a Z or are we working with a T? So they talk about a sample of 50, and of that sample, there was the average household and the standard deviation. So we have a sample standard deviation. So the population standard deviation is unknown. So because the population standard deviation is unknown, we're going to use a T. Okay, so going to use a T and not a Z. So that means that because we're using a T, I need to get the degrees of freedom, and then we will need to get the alpha divided by 2, so that we can get that from the T table. The rest of the formula will be exactly the same as if it was a T or a Z. So standard deviation divided by N. Yeah, I think that is important. Is a lot of lot of times we need to use the t-table. And I think that is what is very important nearly is how to use the t-table. So we are gonna do that for this one as well, and I think there is some others that we need to do it for as well. So degrees of freedom is n minus 1. Then to get to that alpha divided by 2, basically the 100 minus 99%, so that is 1% divided by 2. So degrees of freedom of 49 with the alpha, let me just make 100% sure. 1% is 0.01, and that divided by 2 is 0.005. So that is what we need to get on the t-table. Okay, so let's me quickly go to that again. I should by now actually have it open every time because we are using the same one. Okay, so let's go. Okay, so yeah, so there's in your study guide, it is on page 122. What you guys also have received the TAT 101 letter, and in there the tables are as well. Agree that whole part in the study guide, it really does explain how to use the t-table very nicely. I think a lot of that is quite nicely explained in that. Okay, so let's see degrees of freedom. So this seems like we have probably used some of this previously. Degrees of freedom 49, and we have 0.005, 49 and 0.005. Obviously we used that for another question last time. So let's just, so we sit with 2.68. Okay, so 2.68, 0.005 at degrees of freedom of 49. 2.68. So T is 2.68. Standard deviation is 1,000. Unfortunately, the N is not one that one can just say the square root of it will give us a nice number. So that is why we also have all the decimal numbers. So 3,500 plus minus 2.68 times 1,000 divided by square root of 50. So I'll first work out what the standard error is. So that's 1,000 divided by the square root of 50. That gives me 141,421. And just again, important, they might again just ask you to work out the standard error, even though it is study unit 7. they might bring in that question around standard error again. So 141.426 times 2.68. That gives us 379. And if we round it off to 2 decimals, 0.01. So 3,500 plus minus this will give us at the top end 3879.01, which is option A. And then at the bottom end, just want to make sure that we get the same number. We get 3120.99, which is also that number. So option A. Again, just to show you guys, if we used Z, the Z value would have been, I think, 2.58. So let's see, 2.58. So if we used 2.58 instead of a 2.68, what would have happened is that our answer then would have been option C. So that is where, if you now set option C as your answer, you might get a half or you might get 1 point instead of 2 points, because you still did the rest of the process right. You just had the t value, had it wrong, where you replace it with a z. Okay, so that is where sometimes you will see that you might have a half or 1 out of 2. Okay, what I will ask the lecturer is just how it will be marked in the exam as well, if it is there 0 or 2 points. So I will just make 100% sure for you. Okay, so next question is, and it seems like a standard error, but let's just see what they say. A random sample of size 100 results in a sample mean of 100. The population standard deviation is known to be 15. What is the margin of error for estimating the 99% confidence interval of a population mean? Hey, so this is quite interesting. Let's work out your standard error. So your standard error with a population standard deviation. So standard deviation of 15. So let's just, so standard error is standard deviation divided by square root of the sample size. Okay, so that is 15 divided by 10, which is 1.5. Okay, so that is your standard error. Then they're asking us what's the margin of error. So the margin of error is the z over t times the standard error. So that is the margin of error. So luckily they did not have 1.5 as an option. Um, so the margin of error, and just again, a slight difference in wording. So standard error is we're only looking at this for standard error. The margin of error is this component that is basically giving us how far the confidence intervals is going to be from the mean. Okay, so this part is your margin of error. Okay, so what we will need to do is to times the standard error with your Z. Okay, so that's why they need to tell us if we're working with a population standard deviation or a sample standard deviation. So this one, population, so we know we're working with a Z. 99% is then that your Z is equal to 2,58. So 1.5 times, and let's do it this way around so that we can see the standard error. The Z times the standard error. So 2.58 times 1.5 gives us the number of 3.87, which is B or E. Okay, so there was definitely in this one a mistake. So you could have decided on two answers. If this happens in your assignment, you can choose any one of those two, but what will probably happen is that the question will be dropped out of your assignment if there is a mistake like this. Okay, but the important thing in this one is that we need to work out the margin of error. So just again, careful with this wording, the margin of error, and where the other one. So again, just be careful around the wording. So margin of error, we need to take the standard deviation divided by the square root of n, and we need to multiply that with the Z over T. So they tell us it's a population standard deviation, so that's why it is the Z. Then you can, from the table that is also in your study guide, just once again, the 99, the Z is 2,58. So you can use that. You don't need to go and search it elsewhere. So 2.58 times the standard error of 1.5 will give you a 3,87, which is any one of those two. Okay, so again, something a bit different that you would not have seen in previous questions. The standard error is asked a lot, but this one was the first time that I saw that we're also asking you to work out what the margin of error is. Okay, then a bit of hypothesis testing. So let's read this question, and then let's see what they want us to work out. Most of the schools reported a decline in the number of absences following the education department's learner transport program and school nutrition program. In a sample of 300 schools, 80% reported a decline in the number of learner absent. Okay, so there's just sample of 300. The sample proportion is 80% or 0.8. The district manager is adamant that the true population proportion of schools that reported a decline in the number of absences different from 78 reported previously. Okay, so the population proportion is 0.78. So basically, what they are saying is null hypothesis, and I wanted to go there with a mean, but we are working with a proportion. Adamant that the true population of schools reported a decline in the number is different. Okay, so not bigger, not smaller, it's just not the same, is different. Okay, so the alternative hypothesis is saying that it is not equal to the population proportion, thus we are working with this null hypothesis as it is equal to. Okay, so they just want to see that it is different. So he does not, the district manager does not worry if it is more or less. They just want it and say it is different. Okay, so if we have this not equal to, that means that we are dealing with a two-tail. Okay, so all the previous times that we looked in the last two sessions around one tail and two tail at hypothesis testing, we nearly every time had to look at a one tail, or it was asked to us. So I think this is nearly the first time that I see that in my hypothesis testing that we're actually dealing with a two-tail. So because it's a two-tail, the biggest influence of that will be on our p-value. Okay, so nearly the first thing that I'm going to look at is that p-value, if that will be the one that is reflective of a one-tail or a two-tail. But let's also just look at the other questions. So first, I want to just check the null hypothesis and alternative hypothesis. So under the null hypothesis, the population proportion is equal to 0.78. That is right. So that is what we've written down there. Alternative hypothesis is that the population proportion is not equal to 0.78, and that's also correct. So that is what we have written down there, not equal to. Okay, so then there's three other things. It's it's a mix of questions. So some of it is self-assessment questions, some of it is assignment questions from a previous year. So it is a mixed bag of questions. The session is also recorded, so I will share session and the slides later on as well, but it is a mixed bag of self-assessment questions, previous assignment questions, previous self-assessment questions, and then some of the ones in the book as well. Okay, so let's first work out the t-stat, because from the t-stat we will work out what the p-value is. So the t-stat, because it's proportion, it will always be a z, but I don't always remember what the formula is. I think it's going to be this, so let's quickly go back to, okay, so okay, so let's quickly see the p minus, so sample minus population proportion, so it's 0.8 minus 0.78. That gives us 0.02 over, and let's work that out. So 0.78 times 1 minus 0.78 is 0.22, divided by n, which is 300, and the square root of that. So I get it as something as 0.024. And if I then divide that, I get a rounded off that we get 0.84. Okay, so I get that the t-stat is 0.84. So if we must go and get the z value from the z table, so 0.84. So I want to get this value. So again, just like we did in study unit 7, I can go and say the positive table, get this whole area, then say 1 minus that whole area to get to the green area, or I can go to the negative table of minus 0.84 and get that small area, because remember the symmetry of a z distribution. So let's go, and I need to get the 0.84. And you can see we've done a lot of work here. So let's just do a bit of, sorry, let's just quickly, wrong one. was hoping I could just highlight, but I can't. Okay, so let's get what we need to, minus 0.84, so minus 0.8, 0.84. So we're sitting with a p-value for that small area of 0.2005. Okay. 0.2005, which we see is different to that, but remember two-tail, So here is your one tail, which is 0.2005. Because it's two tail, we will have on the left-hand side the same area, 0.2005. And for two tail, we need to add the two together, which will give us 0.401. Okay, so very important is this is the first time that we're working with a two tail. All the previous questions in the last week and a half, we always only looked at the one tail, and then when we got that one tail, it was the answer. So just for this one, because of the not equal is the only time that we will work with a two tail. So that means that that p-value is actually both of those sides. Okay, and then the last one they tell us is the null hypothesis is rejected. Okay, so let's just clear this. Okay, so just imagine this is a normal distribution. So we worked out our Z value 0.84. So that is 0.84. That was the t-test that we calculated the Z. So now we want to check what is the critical value so that we can evaluate that. So let's see in the question again, what did they say? Formulate the null and alternative hypothesis and conduct hypothesis test of a true population proportion at a 5% level of significance. Okay, so let's see, 5% level will be 95. Are we working with a one or two tail? We're working with a two tail. So my critical value will be 1.96. So my critical value is here 1.96. Okay, so for me to be able to say the null hypothesis is rejected, the t-test must be bigger than the critical value. But here the t-test is smaller than the critical value. So with that, we will accept the null hypothesis. Okay, so we will say there's no difference. So, and the way how I normally draw it is to say, okay, well, here's the critical. If my t value falls within it, I accept it. If my t value falls outside of it, I will reject it. And I will quickly show you on that other slide as well. But let's just quickly check. So falls within, I accept. They said it should be rejected, and that is why option C is wrong. Okay. Just again, a nice slide to summarize this as well is if you want to use this so that you can see if your T-stat that you're working falls on this side, you reject. If it falls within, you do not reject the null hypothesis. Okay, and you can see the same when it is one-tail test, so that you can also have that at hand. So please, this, I thought this is quite um, a nice slide. So what you guys can also do is you can maybe take some of it out, write on it to make yourself notes, to make it so that you can use this slide in your assignments or in the exam as well. Remember, exam, open book, just like your assignments is open book. So you're allowed to use all of these notes. So please, if you want to make copies of it, write on it, make it your own, you can do that. Okay, so this again very similar to the last two sessions we had. All that is changing is nearly the sample size. I think the one you guys had in the self-assessment was 85, I think, the sample mean, or 84. The previous assignment I had was 83, and this one was from last year. So again, not a lot have changed in this question. The only thing that have changed is the sample mean. The rest stayed exactly the same. So let's, before we work out any of these, let's quickly just check what might be right, what might be wrong before we even work out. So T-stat, we will need to work out, so we'll get to that. Then they said an upper tail Z test is applicable. Okay, so if I look at that, that tells me it's smaller. If we go to, where was that? If we see it's smaller, it's a lower tail test, not upper. So this one was actually very easy to say, well, the incorrect one is an upper tail test is applicable because it's not, it's a lower tail. Okay, smaller than is lower tail. If a alternative was bigger than, then it was an upper tail. So it should have been lower tail, so that's wrong, one that is wrong. But let's do all the other questions as well, because that is important. So I just want to, let's move this a bit, or not needed to move. What we will just do is, let's just crop it. And when I've got enough space at the sides to write. And if needed, at the top. Okay. So first thing, let's work out the Z. Just like the previous question, a formula that we work with. And the square root of it. So population. Oh, I went, okay, sorry. I went proportion. I did not even now think about this. I just want, I don't know why. I thought it was, okay, so sorry about that. We're not doing proportions. Let's just quickly take that away. Okay, so we're not doing proportion. So let's just quickly see if it's a Z or T sample, sample mean, population standard deviation. Population standard deviation means that we are working with a Z and not a T. So then we're working with this formula. And let's quickly see. We've got the sample mean is 86. Got the population mean of 80. Got the standard deviation of 16 divided by the n, which this time around is a nice sample, 36. So that will become 6. So at the top, 86 minus 80 is 6. At the bottom, 16 divided by 6 is 2,667. So if we divide 6 by that, we get 2,25. Okay, which is the t-stat. So the test statistic is 2,25. So that is correct. We know which one is incorrect. Let's look at the p-value. So the p-value will be, again, this area where z is 2,25. We work with smaller, so it's only one tail. So we could have actually said, okay, but we need to look only at the smaller side. So let's look at the p-value, 2,25. Again, I will go to the negative table. It's just easier. 2,2, 2,25. So 0,0122, 0,122, which is also correct. So if it was not equal, then it would have been a two-tail, and then we needed to add another piece of that. But because it is only going one directional, it is one tail. Okay, so D is also correct. So let's look at what they tell us in option C and D, because that is now looking at if we're going to reject or not. So let's just see at a 1% level of significance, the rule is to reject the null hypothesis if a p-value is greater than or equals to 0,01. Okay, so if a p-value is greater, okay, so p-value 0,0122 is greater than 0,01. So because of that, we'll reject the null hypothesis, which is correct. But let's also show it on the one where we look at t-stat and critical value. So let's just make 100% sure that that we get this right. So at the 1% level of significance, the null hypothesis is not rejected. Okay, so let's quickly look at one tail, 1%. So that is, let's go to our table. Oh, where's our table? One tail, 1%, 2,33. Okay, so sorry, I have it in my slide pack. Why am I now? Okay, 2,33. So let's quickly again draw that. Okay. So our T-stat was 2,25, I think. 2,25. Our critical value was 2,33. So remember, critical value 2,33 is just a bit bigger. So because it lies, the T-stat lie within, we reject the null hypothesis. Okay, so let's just quickly see what it they say. At the 1% level of significance, the null hypothesis. Oh, sorry, what did I say now? Sorry, this is wrong. I'm now making myself. Let's just quickly check. That normally is accept the null hypothesis. Sorry, not reject. Because it lies within, accept the null hypothesis. The other words that they use then is do not. Do not reject. And I've got a question on that as well in this pack that we're going to look at. So accept the null hypothesis. Again, we can look at that one. It lies within, so we do not reject the null hypothesis. The other way to not reject is that we accept the null hypothesis. Okay, so null hypothesis is not rejected. Okay, so, and again, here is how we will look at it. Okay, so just again, I like to draw this picture for me because it's sometimes just easier to see it on a picture than trying to look at the numbers. But you can also nearly write out a formula to remember. So if critical value is bigger than your T-stat, you can say if critical value is bigger than your T-stat, you not reject the null hypothesis. If T-stat is bigger than your critical. So then it would have a line on this side. Then we reject the null hypothesis. Okay, so if you want to nearly learn that as well, it's also a way. So if critical is bigger than T-stat, you do not reject. If your T-stat is bigger than your critical, you will reject the null hypothesis. Okay, so let me quickly, I wanted to, so where was that? I want to bring that actually in now. Where I had one with all the different options. I will check where that is so that we can just look at. Okay, that's weird. I will check for you, and then I will bring that into a session on Sunday. I just want to check quickly, guys. I thought I had one with all the different rejection and not rules, so I will just bring in one of those questions. Let me quickly, I just want to search for that. I know I had one, so let me quickly just check. I wanted to put that into today's session. So let me quickly just see where that have fallen off and why I don't have it. Let's check that it was previous exam papers, and it's weird. Yeah, at least I know what the question I'm looking for. So what I will do is just check that we cover it at least till on Sunday. But I just want to look at one more of my files. So let me just quickly. Let's hope it's in this one. Okay, it's not. Okay, I'll check. I have it somewhere, so I will just get it for you. It is one question that basically asks four types of reject or accept and things like that. So I will just check for you guys so that I can just show you that question as well. Okay, so let's just look at a few more. So specifically, again, I'm looking at hypothesis testing. So calculate the p-value of a test of a following hypothesis, given sample proportion of that, n 100, and calculated t-stat equal to z is equal to 0.05. And then they give us the population proportion as well. Okay, so they give us the z value. So we can go to the z table immediately nearly. So we can go to the z table, but let's look at where is that z. So remember that is 0. So that z is just a bit bigger 0.05. Okay, so let's see what is this area in green. 0.05. Sure. 0.05, 0.05, 0.4801. And so that is really 0.4801. Because it is one directional, it shows us bigger than, so it's one tail. Because it's one tail, we only need to worry about the one side. So our p-value is 0.4801, which is option 1. Okay. If it was a two-tail, so if it was not equal to, there's probably not an answer for that, but then it would have been 0.4801 times 2. So if it was then a two-tail, it would have been 0.9602. Okay, because then on the left-hand side, there would have been an extra 0.4801 for the p-value. So again, just it is one tail, only looking at the one side, which is 0.4801. They've given us the t-stat, so you don't, in the exam, I think the one thing very important in the exam, read the full question. I know the last time we looked at a question like this, I was starting to work out the Z value already, but they give it to us. Okay, so again, very important in the exam, your time is going to be much more limited than it is now in the assignments. So sometimes we misread some of the questions and then it takes us a bit longer. So here they already gave us the Z, so we didn't need to actually work out the Z. It was already there. So we could just use that and then gone to the table. Okay, let's look at the next question. So again, one of the previous assignments, again, I think it was last year's one that we looked at it. So let's just see what again is in here, what we need to work out as well. So, and if it is very in line with some of the other questions. So most of the schools reported, so again, you can see last year this was nearly, the questions was around, everything was nearly about learner transport. So in a school of 200, 72% reported to decline. Why does this look so familiar? Okay, so look at this question came out of your self-assessment questions this year. So this one came out of the assignment of last year. Okay, so you guys can again see a lot of the questions, very similar questions nearly coming out. So with just a bit of information in it that is different. But nearly all the other things very similar. So let's quickly see. Okay, there's nothing. Okay, we can look at, here's a part of alternative hypothesis that we might work out, but for others we nearly need to work out the answers. So district manager is adamant that the true population proportion of schools that reported decline, the number of absent. So there again, it's different. So the alternative hypothesis tells us that it is not equal to. So that has stayed the same in the question. The only thing that they've changed is the sample size and the sample proportion. So the alternative hypothesis is that the population proportion is not equal to 0.78. So that is correct. Okay, so then to get to a p-value, we will need to work out the t-stat. So let's work that out. So z is equal to the sample proportion minus the population proportion divided by population proportion, remember, times 1 minus. And that divided by n, which is 200. Wait. Okay, so let's see if that is going to be the same. So 0.72 minus 0.78. That already gives us negative 0.06. So that is going to be wrong because this is going to be a negative number. But let's just see 0.78 times 0.22 divided by 200, and the square root of it is 0.053. So if we divide those two with one another, yeah, I get 1,134 minus 1,134. Please check if that is what you guys are also getting, but that tells me that obviously the t-stat is wrong, but the t-stat is already wrong because that is negative. So let's just check around the p-value. So minus 1,134. Okay, so what I would have done is 134, I would have rounded it off to 1,14. Oh, sorry, 1,13. So let's go to our z minus 1,13 minus 1,1, 1.1. Oh, why does this feel wrong? So let's see where I made a mistake here. This does not feel correct. 0.72 is right. So let me just check this again. 0.78 times 0.22 divided by 200. Take the square root of that. Okay, that is a different number. Okay. I wanted to say that did seem wrong. So 0,029. Okay. Better, minus 0,05. Okay. Okay, still the t-stat is wrong because the t-stat is negative and not positive. So that is still making it wrong. So let's get negative 2.05. Let's get that p-value minus 2.05 minus, and let's quickly, 2.05, 0,0202, 0,0202. Hey, remember we're working, if alternative was not equal, so we're working with a two-tail. So on this side, there also needs to be a 0,0202, which makes the p-value 0,0404. Hey, so the p-value is correct. Then let's look at, we can conclude that the proportion of schools that reported a decline in the number of absences is significantly different from 0,78. So let's look, we tested at a 5%. So let's just see, and let's do it this way. We tested at the 5%. Remember, our t-stat was minus 2,05. So if our critical value lies within, if our t-stat is bigger than our critical value, so depending if it lies within or without, we will reject or accept the null hypothesis. So let's look at, we're testing it against the 5% level. So also important, they give that to us so that we can go to that table. I'm going to take this one out, take that one out. So 5% level, we were testing it against two-tail, 5% level, again 1,96. So just remember 1,96, but then it will be on the negative side, minus 1,96. So that is our critical value. So if it was on the positive side, the t-stat would have been 2,05. And your critical would have been 1,96. So critical is smaller than your t-stat. Okay, so if that is true, what happens? Critical smaller, we reject the null hypothesis. Let's quickly see. We conclude the null hypothesis is rejected. So if a null hypothesis is rejected, we accept the alternative. The alternative says that there is a difference. So we can conclude that the proportion of schools that reported a decline in the number of absence is significantly different. And the reason is we reject the null hypothesis, which is right. So that is in line with option D. Because we reject the null hypothesis, which is, remember, the null hypothesis says that the proportion is equal to, so we reject it. So we say, hang on, it is not equal to. So it differs from your null hypothesis. So it differs. So it is significantly different. Okay, so that is the one thing out of hypothesis testing that is very important, is that so when we reject the null hypothesis, that means that we accept the alternative. So if your null hypothesis was, now in this instance, alpha was equal to 0.78, sorry, not alpha, your population proportion. So reject null hypothesis. So we say that is not true. So by rejecting the null hypothesis, we're basically saying, okay, your alternative hypothesis is true. So my alternative hypothesis says that my population proportion is not equal to 0.78. Okay, so that means that it differs significantly. Okay, so just nearly again the language that is used in this. So when you reject the null hypothesis, you accept the alternative. So your alternative hypothesis then is true. Okay, so if it was this one that was true, then it would have been that we would have said, okay, but our alternative hypothesis tells us that the population proportion is bigger than 0.6. Okay, so that is nearly the important thing out of hypothesis testing. That is really important is the way, here's the question actually, the way that they structure it, and what you need to know about accepting and rejecting the null and alternative hypothesis. Okay, sorry, here was the question that, and I think there was one like this in your mock pack, or your pack that you guys also went through. I'm just hoping that there's not an option E that was not sent last year. Okay, so here you guys can see nearly, so we do not reject, there's not enough evidence, we reject, we do not reject. Okay, so already there is different language being used between all of these. So let's first read it, write down our hypothesis, and then we'll check if we need to work out anything or not. But various literacy groups recommend a reading speed of, this is very similar to the one that we had on Tuesday, of 119 words. I think then it was looking at grade 6 or 7 learners, of 119 words per minute. For grade 2 learners, a grade 2 teacher is convinced that the average reading speed for her class is different from a recommended reading speed. In a sample of 36 learners, grade 2 learners, the average reading speed is 111 with a standard deviation of 21. You are required to test the teacher's hypothesis at a 5% level of significance that a grade 2 class reading speed is different from a recommended reading speed and choose the incorrect statement. Okay, so that is the population. So the population proportion, the null hypothesis is that the population proportion is equal to 119. The alternative hypothesis they talk about is different. So alternative hypothesis is not equal to 119. Okay, so that is your two hypotheses that we are dealing with. Then let's quickly see the sample, average reading. So sorry once again. Now I always in these ones now wanted to go to proportions. I don't know why I'm doing that. Okay, so it's a mean. We're talking about the mean. Don't know why I went for proportion. I did it now twice tonight. Okay, so it's actually means, not proportions. Sorry about that. The head now is just going one way. Okay, so working with a mean. So let's just check, because it's a mean, we need to decide if we're working with a Z or T. The way that we calculate that Z or T is exactly the same. So the formula for the Z is also from study unit 7, is your mean minus population divided. If it is T, it looks exactly the same. The only difference then is that it's a sum, and by that it needs to be a S. So that's the only difference that comes in. Okay, but the rest of the information is exactly the same. So what we will work out doesn't matter. It is then how you use that to go to your Z table or T table. So let's quickly check again by telling us that this is a sample, and of that sample, the average is 111 with a standard deviation. So we know that we're actually now working with a sample, so we don't have the population standard deviation. So we don't have a population, so this is going to be a T that we are working with. I think it's very similar to a question we covered on Tuesday night. And the sample was 37. Just remember, with a T, the sample is still 37. You're not, while you're working out the T, in this instance, we're not looking at degrees of freedom or anything like that. We just want a T value. Okay, so 111 minus 119, that gives us minus 8. And then 21 divided by the square root of 37. I get 3,452. So that tells me that T that I'm going to test with is equal to, I hope this is right, minus 2,32. Okay, so T distribution, Z distribution, if you look at that graph, and we're going to look at the table now, looks very similar nearly. So let's just redraw that. Okay, so here we are sitting with our T-stat of minus 2,32. So if our critical value lies on this side, okay, so let's first look at where it is before we make that decision, because it's again going to also be in the word. So test at 5% level, 5% level, and it is two-tail, but it is a t-test. So let's quickly okay, so let's just quickly check 5%. So let's take all of this out. No, let me just do that again. Just quickly, if there was a quicker way that we can just work with this. Okay, so let's quickly check degrees of freedom. So we're looking at 37 minus 1 is 36. So there's our degrees of freedom. That is at 36. Then remember, we're working with the 5%, 5% significance level with two-tail. So two-tail means that there must be 5%. So let's quickly, so how big will that area be that we're looking at there? How big will alpha be? Okay, so for this one, we need to look at 36 with alpha 0,05, but because it's two-tailed, it's 0,05 divided by 2, so 0,025. Okay, so we have our critical value is degrees of freedom at 36 at 0,025, it's 2.0281. 2.0281, 2.0281, so minus 2.0281. Okay, so it lies within, not outside. So let's quickly let's look at our picture. Okay, so lower critical value. So the critical value was 2, or minus 2,002 something. The T-stat was minus 2,32, I think. So from this table, what we can see, oh well, that means we're gonna reject the null hypothesis. Okay. So critical value minus 2,002. The T-stat that we worked out was minus 2,32, lies without that. So reject null hypothesis. Let's quickly check. So let's just write down that we remember we're going to reject the null hypothesis. Okay, we do not reject the null hypothesis. Okay, so that one is wrong. There is not enough information provided to decide. That is wrong. We reject the null hypothesis. Okay, and conclude that grade 2 average reading speed is not significant different. So reject the null hypothesis. And then we conclude that it is not significant different. Ooh. We reject the null hypothesis and conclude that grade 2 average reading speed, is not equal, not different. Sorry, I was now. So that's wrong, that's right. So we can conclude that it is not different. Okay, sure. Again, these ones are quite difficult because it's easier if I just said reject the null hypothesis or accept or reject the alternative hypothesis. So, but now a lot of it goes also into the wording. So just look at, we do not reject the null hypothesis and conclude that grade 2 average reading speed is significant different. Okay, so again, very important how we read it, and the wording that goes with it. Okay, so very important So the first thing is that we do not reject the null hypothesis. Sorry, we reject the null hypothesis. So that means that we can already eliminate those three options. I think there was an E option as well, but yeah. Okay, then just a last one. So I know we did this earlier in one of the assignments as well. Or in one of our sessions. So I just wanted to repeat something like this, so that we just get the understanding around the null hypothesis and the alternative. So the professor of statistics refuses the claim that the average student spends 3 hours studying for the exam. Okay, so he's not saying students spend more or students spend less. He's just saying that they're not spending 3 hours. Okay, so the alternative, the null hypothesis, alternative. So alternative hypothesis is they are not spending. The not spending is not equal to 3 because not equal to your null hypothesis will be it is equal to 3. Okay, so that is wrong. Null hypothesis is equal. Alternative is not equal. Null hypothesis is equal. Null hypothesis is equal. Alternative, so here it should have been read. A professor of statistics claims that the average student spends less than. So if that was the case, it should have said something like less than and not just different. Okay, so that is, and then what we're testing here is not population. What we're testing here is sample. Hypothesis testing, we will never test a sample. We're always testing if it is different from the population. So we're always saying, well, we're looking at the sample, but we're always going to test if it is different from the population. So we're never going to test if it's different from a sample. We're always going to test it if it is different from a population. Okay. So that is just again quick recap of this one to just again show you the differences in all the options, and just in how again depending on what the words are, how you then need to interpret it. Okay, guys, this is it for tonight. We will have a quick check-in session on Sunday again on this. So again, please, what is always good is if you can try to submit more